Hi, my name is Anik Hazim bin Badrul Hizaman with metric number S60069. Today, my friends and I will present about Project 2 influence of the cache size, which consists of member of my group. There is Ahmad Amnan bin Ahmad Isham S5802925 and Muhammad Shabib bin Abu Bakar S59580. Content of this slide: introduction of the project, simulation task, result of the simulation, discussion on the task, conclusion and project contribution. Introduction to this project: definition and rationale. Cache memories are small, high-speed buffer memories used in modern computer systems to temporarily hold those portions of the contents of main memory which are believed to be currently in use. Information located in cache memory may be accessed in much less time than that located in main memory. For reasons discussed throughout this paper, thus a central processing unit or CPU with a cache memory needs to spend far less time waiting for instructions and operands to be fetched and or stored. Cache memory is used to reduce the average time to access data from the main memory. The cache is a smaller and faster memory which stores copy of the data from frequently used in main memory location. There are various different independent cache in a CPU which store instruction and data. Cache memory is an extremely fast memory type that acts as a buffer between RAM and CPU. It holds frequently request data and instructions so that they are immediately available to the CPU when need. Okay, for the next slide is simulation task. What we need to do is we had to use SMP cache with following the configuration of the system by using given architectural characteristic. We have been assigned to do a project 2 as instructed by our lecturer. By using the format of the system SMP cache, based on the purpose that we need to identify and show the influence of the cache size on the miss rate. We also need to configure our SMP cache system with the following architectural characteristic by following the processor in SMP is 1. Cache coherence protocol is messy. Shame for bus arbitration random. Worldwide bit 16 words by block. System with block size 32 bits. Block in memory 8192 with main memory size 256 KB. Mapping fully associative and replacement policy LRU. Okay, that's all for me. Thank you.
Alright, for the CEXP memory trace result. As we can see, our group have present a graph here for the result simulation test. This is for the CEXP. Based on the bar graph we done, the improvement of the cache hits and the decreasing of the total cache miss depends on the increasing of the cache block size. The blue one is the cache hits. The orange is the cache miss. You can see the increasing of cache size here will increase the number of cache hits. Next, the cache miss start plunge down. It start to decreasing between the block size 8 and 16. That which the percent for the size 8 is 38.53%, while for size cache 16, 38.52% of percentage. It's quite bit different there in the percentage. Then we can see that increasing the cache block size will make the cache hits increase and the cache miss rate will be decreased indirectly. We go next for the COMP. In the COMP, we can see the improvement of the cache hit and the decreasing of the total cache miss after the cache block has been configured as ascendingly from 2 to 51 to 512. See, start from the size cache block number 2 to 512, it's decreasing the cache miss. When the cache block on the value of 2, we can see the percentage of the cache hit improve drastically from 34% to 62%. Then the number are slowly increase as the number of cache block increase. Okay, the number of cache hit in COMP increase depends on the increasing of the number of cache block. We go to the EAR memory trace result. We see the enhancement of the cache hits based on the bar graph we made, and the decrease in overall missing cache depends on the increase in the size of the cache block. Yes. So between the number cache block size 8 here and 16, the missing cache began to plunge down with 24% of the cache miss going down, while the cache hits increase 16%. The number then grows steadily as the cache block number increase. We can see the number of cache hit still increase with the increasing of the number cache block. So for the discussion.
Hello, and my name is Shabil. I will continue the slide. Okay, discussion about the task. In this experiment, we may observe the grade cache, the miss rate is stabilized. Why? We can also see the grade different miss rate at the concrete increment of cache size. What does this grade different indicate to this grade miss rate appear to the same point of all program? Why? First, we can know that at the large cache size, at the degree of miss stabilized because of the compulsory miss. Compulsory miss are those the miss caused by the first reference at the datum. As cache grow, compulsory miss increase in proportion to the other type because incapacity miss decrease by improving overall cache performance and do not result the focusing on the just type of miss. The more cache have, the more likely the register to hit the memory access. Because fewer memory locations are forced to share same cache line, they happen when we first double the cache. The degree of the miss has decreased when increasing the block size because in this way, we increase the number of the words data in each block cache because the special locality sees probability in near future. For accessing close data to the access word increase. Okay. Does the increased cache size improve the system performance? We can say the increased cache size did increase the system performance and efficiency, but not until some point that increase the cache size are not very helpful and effective to increase some system performance and efficiency. Okay, the conclusion and project contribution. We can conclude the project group assignment has been very beneficial in learning more about what we have learning during class, especially about computer memory system in computer organization and architecture. It also make things clear since we will be programmer and we must know how the computer works since we are going to develop software which will be very helpful when we're completing program coding. Together as a team, we have done all wonderful job working together and encouraging each other to happily finish this project. Each participating is really committed to doing and addressing their located tasks together. Last but not least, thanks to the great support of the team members, we are finally successful completing this project and having complete understanding of the objective of this project. Okay, that's all for this slide. Thank you for having us.